Good morning, everyone. Let's get started. My name is Diana Cheng. I'm a senior solutions architect at AWS. I'm happy to be here this morning. Thank you to our JCON organizers and, of course, to our kind sponsors for this opportunity and for making this happen. I would like to start by setting the scene a little bit of what we're going to be discussing today in this session. I'd like to provide you an overview of AWS CDK. So what the problem it is that it tries to address, what are the advantages of using it. And it's an introductory level session. So for those, it's really aimed for those that are still new to CDK. If you're familiar with it already, then it can serve as a refresher, but not more. We will have examples in the Java language, and it assumes some working knowledge of AWS so that you've used some of the services before, but of course not in any advanced level or so. We're also going to talk about how to manage our infrastructure and code through reusable components in CDK and how to integrate that also in a deployment pipeline. We're going to we're working with CDK version 2. And I'll also present at the end other projects that are inspired by the philosophy of AWS CDK and that now form part of an open ecosystem of CDK projects. At the end, we're going to have time for some Q&A, as already mentioned by our host. And yeah, let's start discussing infrastructure management. So how we manage our infrastructure in the cloud, for example, in AWS. And if we take a look at how we really get started with provisioning infrastructure, typically we start by going to the AWS console. So we start clicking around and provision manually our infrastructure through the web interface. And that's a very easy way to get started, but it's pretty manual, right? And it's not reproducible. So every time you want to create the same setup, you need to do it again manually. And at one point, as more people start working with your projects and your environments grow, then this starts to become more error prone. More people will make more mistakes, and more times that you attempt is going to make everything more error prone. And it's also time consuming, right? Every time that you want to replicate the same, you just have to do it all over again. It's not really automatically reproducible. So we are looking at, around for better ways to do this, and we would like to automate this kind of process, of course. And we can use the AWS CDK for that. So the AWS CDK is the library that we use in our code to speak with AWS services, to call APIs for these AWS services. And we start by telling through lines of code, telling our program through lines of code what it needs to do in order to provision in our infrastructure in the cloud. What are each of the steps that it needs to take in order to, in order to provision that infrastructure. And the problem with that is that we're really telling it what to do in order to provision from scratch, and we don't really have an approach with that of how to manage changes. So how do we go about when we just want to change or update that infrastructure that is already in the cloud? How do we manage rollbacks if a change didn't really work? Or how do we get notified when our infrastructure is ready, when it has already been provisioned, or when the change has actually happened? We don't really have any feedback into what are the lifecycle events of our infrastructure in the cloud. So we look for a better solution, and we come across the so-called provisioning engines. Engines like CloudFormation or Terraform. And these are really powerful tools that allow us to change the approach that we took previously and move into a declarative approach. So we go about declaring the state of our infrastructure. What is the desired state of the configuration that we want to have in the cloud? And with that, the provisioning engine is the one that will take care of the figuring out what are those steps that need to be taken for our infrastructure in the cloud to reach that desired state. We don't have to do that, and that's quite some bit of heavy lifting that gets done for us. And this is also automated, right? It's easy to automate it by writing this desired state configuration files, and then it's automatically reproducible. Every time we want to rerun it, then we just apply the same template, and whether it's simply an update, we simply modify the desired state and we apply it again, and that's already a much better approach. These provisioning engines are really powerful, and as I said, they let us provide the desired state of our configuration through templates. CloudFormation works with JSON and YAML, and Terraform uses mainly the HashiCorp configuration language, or HCL, although I know it also supports JSON. And what happens with that is that basically those templates are passed into that provisioning engine and get applied. So that means that the provisioning engine takes care of our resources getting created or updated in the cloud, and then we end up with those resources. And that was easy to do and reproducible. But the difficulty starts when we really work more and more with these configuration files, and when we create larger architectures that we want to deploy, then very easily or very quickly, these files can become very large because the configuration syntax is pretty verbose. And we don't really have any abstractions that we can reuse. So whenever we want to reuse something, it's mainly around copy pasting snippets from these templates, and that's not really ideal. They also force us to provide a lot of details about the infrastructure that we are trying to provision or update. And what I mean with that is that it's easily clarified through an example. These files really will become pretty easily large. If we take a look at this example, it already is 92 lines of YAML file, and what I have here is nothing else but a CloudFormation template that describes a website that is fronted by a CDN. So in our mind, this is nothing else but a CloudFormation distribution and an S3 bucket that hosts a static content, that hosts a static website. Excuse me. And this is pretty much the simplest service composition that we can have. And nonetheless, we already have, and you can see the example in the website that I have here, we already have 92 lines of YAML. So imagine if we have a more complex service composition, this we can reach hundreds of lines of configuration template files very easily. So this is where the motivation for the AWS CDK comes from having to deal with this complexity of managing very large and not really reusable template files. And as I said, as we really compose more services, this will become more obvious how large and difficult to maintain they can become. And also the reusability aspect. So having abstractions for reusing those patterns that we're used to implementing. If we think about services that typically work together, for example, on AWS, a composition such as an API gateway proxy and a Lambda function to implement a REST API, that's pretty common to do. And so we start thinking, how can we model that? And how can we reuse it again? And what if we could do that with our favorite programming language, right? So through code, really. And that's exactly what the CDK brings to us. So it's a developer framework for defining infrastructure and cloud resources via code and with reusable components. We're going to see what these reusable components are. And it will happen with our preferred programming language. And we're going to implement those reusable components through classes and methods in those classes. And because we are working with programming languages, we're going to work with familiar tooling for us. So we're going to use an IDE, which is going to provide us auto-completion, inline documentation, all these nice goodies that come with using programming languages. And another characteristic that makes CDK really, really nice is that we won't have to provide all the details that we needed to provide previously through the configuration files. There you really need to provide pretty much every single mandatory property that your infrastructure in the cloud needs to have. CDK will actually assume a lot of same defaults if you don't provide all the other properties that are required. So it's going to make those assumptions for us. It's going to be a little bit opinionated in what it does unless we tell him otherwise. And yeah, as I said, it's based on components. So all these classes are that we're going to implement are going to be reusable, and that's going to make the development of infrastructure as code much easier. So when we get started with AWS CDK, we really always start with the CDK application. That's where everything, that's our starting point. And this is the topmost object in CDK. When we think about CloudFormation, the stack is a topmost object. So if you've worked with it before, you will know that you deploy a stack that is the unit of your infrastructure. In CDK, we will deploy our stacks, but they live within the scope of a CDK application. Within that application, we will declare our stacks. It can be one or more, and they could span one or multiple AWS regions. Within those stacks, our constructs, so our reusable components, are going to come in. We're going to build what we know as a tree of constructs within a stack and within a CDK application. And we're going to see in a minute what I mean with a tree of constructs. We're going to have one or more within our stack, and constructs are really the key abstraction. This is where the configuration of our cloud resources goes. So we can declare one cloud resource, such as a S3 bucket, or multiple of them. It could be a DynamoDB bucket. It could be several services within one construct. And we're going to take a look at how that works. The very interesting thing, or quite nice, I think, is that CDK actually builds on top of CloudFormation. And this is nice because CloudFormation is a proven and solid provisioning engine. So, and most of us are already, or a lot of us are already familiar with provisioning infrastructure in this way. We work with configuration templates, but we are no longer going to do that. We're really going to do this via code, via CDK. And behind the scenes, we're going to synthesize our CDK application and stacks into a CloudFormation template. And this template is going to get applied. It's going to be taken by the CloudFormation engine, and that's going to be how our resources really are provisioned. But we moved away from having to declare templates and doing this via code. And the nice thing is that if you are not sure what's going to happen with your CDK code, you can always go and take a look at the generated CloudFormation template, and that's going to give you an idea of what's happening, and you can also debug easier with that. It's supported by in multiple languages, as I said. So we have the CDK libraries in multiple languages: TypeScript, JavaScript, C#, Java, as we're going to see in this talk, Python, and also Go. So as I mentioned, we have a tree of constructs that we declare as part of our CDK application. And this is because every construct is instantiated in the context of another one. We start with our CDK application. That is something that's an object that we instantiate, and it's going to become the scope for us instantiating our stack. So we're going to instantiate our stacks, and we're going to pass that application, that CDK app, as their scope. And when we are declared constructs, we're going to use the stack as the scope for them. And constructs can also be declared in the context of other constructs. So that's another construct can also work as a scope for a different one. And these constructs are going to have a unique identifier, or an identifier that needs to be unique only within the scope of the construct. And that's going to allow us to import constructs that were implemented by somebody else, or that we find online, for example, in a package repository. And we're not going to have that problem that the identifiers within our application end up clashing with each other, because they're only going to be unique. They only need to be unique within the scope of each construct. And that makes reusing external components also easier. Moreover, because we're working with code and with reusable components, this opens the opportunity for unit testing, or for testing our components much easier. And much easier than what we could do with the templates that we worked with previously. There are several components that are part of the AWS CDK. The first one is the core framework itself, so the library implementation. That is what we're going to include in our Java CDK application as a dependency, and it's going to help us, develop that code. We're going to import some tons of statements. We're going to instantiate some of the classes that are declared there, and we're going to instantiate finally our code into a CloudFormation template by a process called synthesizing. I'm going to see that in a minute. CDK also comes with CLI that's similar to the regular AWS CLI. If you already know that, it's a command line tool that basically allows us to initialize application via for example, the CDK init command, to synthesize our code into a template by using CDK synth, or to look at the differences between what we have in the cloud already deployed or not deployed and the state of our code, so we can review those differences before we actually go ahead and deploy or provide an update via using the CDK diff command, and of course the command to actually deploy it with CDK deploy. So we're always going to need the CLI, so that's a mandatory installation when working with CDK. And another thing that CDK brings us, which is of course part of the library itself is the construct library. And what this is that collection of constructs curated by AWS and part of the CDK library that are going to have a representation for each of the services that we're going to work with. So each AWS service will have a construct representation in as part of the CDK library, and those are the ones that we're going to be using. They are going to be the ones that we include in our infrastructure, and they're going to be the basis for us to build on top of. We're going to build our own reusable components by first taking those constructs in the construct library. So I've been mentioning constructs, and there are different types of constructs. That's an important characteristic. There are kind of levels of sophistication or complexity of the different constructs, and that's because each construct level or each construct in the different levels does different things for us. They will have different extents of how much they do for us behind the scenes, how much they assume from us. And we have constructs level 1, which are the simplest form, and they're nothing but a one-to-one representation to CloudFormation resources. So we're going to see that in a minute. When you translate that L1 construct and synthesize that, you get the direct representation of CloudFormation in YAML or in JSON. So pretty much we can do with these constructs exactly the same thing that we did with CloudFormation. We work with them in a very similar manner. Then we have construct level 2, and these are higher level constructs. They are also called curated constructs, and they also relate to a single service, for example, the AWS VPC or AWS EC2. But under the hood, they're going to do already more for us. They're going to wire more things up together, and they're going to be the constructs that assume what I mentioned as same defaults when we don't provide all the properties required. These are also part of the CDK library. You're going to see many of L2 constructs as part of the CDK dependency. And we have then the level 3 and higher level constructs. These are definitely more opinionated constructs, and they're also called pattern type of constructs because they can really wrap complete architectures in them. And these are the ones that we are typically going to be building as reusable components or writing as reusable components. You have some of them already part of the CDK library, but not many. So we're going to see how that works. And we can write these constructs ourselves, for example, to share them within our company, to establish organizational patterns or best practices, or we can publish them as package in a repository manager like Maven, or we can publish the code publicly on GitHub as well, for example. So this is where we really start sharing and reusing logic for our cloud infrastructure. So let's clarify this a little bit more with some examples. The construct level 1, as I said, is really a representation of a CloudFormation template. And the naming of these constructs is typically starting with CFN, so CloudFormation, and then the name of the resource that we try to create. In this case, I have here a CFN bucket, a CloudFormation bucket, and I'm instantiating this via the constructor, providing the scope of that, where that construct is going to live. So I'm providing the word this, because the class where I'm working with this code is going to be the scope for this construct. I provide an ID that's also a mandatory parameter or argument in the method of the constructor, and I'm passing a property. I'm using a builder object with a method to build a properties object and to provide the only mandatory property for an S3 bucket, which is the bucket name. And if I were to synthesize this, or if I were to use the CDK CLI and use the CDK synth command to synthesize this into a CloudFormation template, then what we get is nothing more than a small snippet of CloudFormation, which has exactly that same resource one-to-one. I declare a bucket and I get a bucket. And it has that single property that I use, the only mandatory one, which is the name of the bucket. So that's pretty straightforward, but it gets more interesting with construct level 2. And I can declare one related to a service, as I said, such as the VPC. I'm not passing any properties in this case. I'm simply instantiated the construct. And that's kind of a very common object or resource in the cloud that a lot of AWS architectures start from, the VPC. But we know that VPCs really have a little bit of configuration that they need to take. So I'm only declaring this construct or instantiating this construct by the method and not providing any properties. But if I were to instantiate this via the CDK synth command again, we will end up with a VPC that actually looks more or less like this. It will encompass more than one availability zone. It will have 4 different subnets, to public, to private. It will have inbound internet connectivity by using an internet gateway, and the private subnets will also have outbound internet connectivity because there is a NAT gateway as well. And we didn't have to specify any of that. That is the same defaults that CDK assumed when we didn't pass any other properties specifying the characteristics of the VPC. And exactly what same defaults CDK is going to assume, we can find it in the documentation. So the Java doc that you can pull up when you are coding as well will specify exactly what CDK is going to do when we don't provide the properties object for the VPC, in this case, as an example. It's dividing the CIDR range equally between the subnets. It's, as I said, creating an internet gateway for you, the NAT gateway as well for outbound internet connectivity, and all of that just was assumed by CDK because we didn't provide the properties for that. If we take a look at construct level 3, then there is even more of this that gets assumed. We can, in this example, we're declaring an ECS cluster, and we are simply specifying what container image we want to pull from a specific container repository. And they were saying that we want an ECS service that's going to use Fargate and that's going to have a task that is simply built based on the container image that we pass. And that's just 4 lines of code. But if I were to again synthesize this, we will actually end up with more than 100 lines of CloudFormation template and with a deployment that looks more or less like this in our AWS account. It will have declared the VPC for the ECS service to run in. It will have declared the service using Firegate. It will have configured all the things related to the VPC and to the Elastic Load Balancer, including the security groups to allow inbound access. And pretty much we didn't do anything by specifying the container image and declaring 4 lines of code. And we ended up with a full architecture. And this is the idea with the AWS CDK. We're going to have this high-level constructs that we can implement ourselves or that we can use from the library or from other sources that we import, and that's going to make it our declaring our cloud infrastructure much easier than it would have been with 800 lines of code in a CloudFormation template. Besides the level 3 constructs that you have as part of the CDK library, which are only a few actually, we also have an extension, an open source extension of the CDK in the form of an open source library, which is published as the AWS Solutions Construct. And these are basically small multi-service patterns that follow what we call the well-architected characteristics of AWS. And we can go to this constructs page and we can look for what patterns already exist that are commonly used and that we might be able to just take from there instead of implementing from scratch. So here you will find common implementations such as an API gateway fronting a Lambda function, as I already mentioned, or fronting DynamoDB. This typical small service compositions that we often work with, you can find them there. So it's worth taking a look before you decide to implement that yourself in case that's useful. As I mentioned, the current active version of CDK is now version 2. It was in developer preview for a few months, but was released last year in December during the last edition of the reInvent conference. And it addresses a few major pain points that developers came across when working with CDK version 1. And one of them is, or the most important of them, is the dependency management. In version 1, pretty much for every service on AWS that you wanted to declare resources for, you had to import a separate dependency. That's no longer the case. The version 2 library is implemented as a single package, as a single jar file in the case of Java. And that simplifies dependency management, because when developers were importing multiple libraries, one per service, they ended up having different versions, or different minor or major versions of the libraries, and that created conflicts and errors. Excuse me. So that's now simplified. Version 1 still receives some updates, particularly for level 2 constructs, but it will continue to receive updates for new and updated level 1 constructs as well, but only until June next year. At that point in time, version 1 will reach end of support, so you're encouraged to upgrade already. There is no reason why not do that, particularly because everything that is included in version 2 is stable. Previously, experimental features were also part of the libraries within version 1. That's no longer the case. Now there is a clear separation between a stable and experimental module. So everything that you find within the CDK library in version 2, that's stable, you can count on that. And everything that you want to try as a new feature that is still in preview or as an experimental version, then you will have to import as a separate module. And this module will have clearly a difference in the name. It's going to be minus alpha in the name. So you can very easily know what you are working with that is supported long-term and what is things that are subject to change. Besides from these improvements, also a lot of new constructs made it from experimental features into stable ones as part of the new CDK version 2 library. And of course, we have many more new constructs that have been included. So before we look at how we might start implementing or working hands-on with it, just want to review the prerequisites for CDK. The Node is the main prerequisite, so you need version 10.3 or higher. You need to install the CDK toolkit, so that includes the command line as well via using this command from the npm package manager. This is the same command that you can use to upgrade to version 2 from version 1. But of course, if you need to have both versions for some reason locally, then don't run this command again globally, because that will overwrite your version 1. You can verify that the CDK has been correctly installed by printing the version of CDK. And now I just want to walk you through a very small minimalistic demo, pretty much the smallest service composition that you can have on AWS, just an API gateway fronting a Lambda function, implementing our REST API endpoint that we can invoke via get method, and the Lambda function then provides an HTTP response, just saying hello. So I want to take a quick look at that, and I will share my other screen now. And yeah, I want to share that. So my new screen should hopefully be visible now with the command line interface. So yeah, the first, just to show you, the first thing we do the first thing we can do is really run the CDK init command, right? That's how we can initialize new applications. So if I run CDK init without specifying anything else, it's going to give me a detail of what I can do with this command. I can do CDK init app, for example, specifying the programming language of my choice to create a new CDK application. If, for example, I wanted to have some sample code, I can initialize a CDK sample app. And that's going to create a skeleton of an application for us with already a CDK app in it and a small stack within it. But typically what you will do when you want to create a new application is say this, and then we can specify Java as the programming language. The lib argument is when you want to start developing reusable constructs that you want to make available in multiple languages. And that's why it's only TypeScript that is available, because when you want to use the library GSI, which is what allows CDK to be in polyglot, you would typically write it in TypeScript and then you use GSI to compile this to multiple languages. And then you can get it available in Java and whatnot. I could initialize an application now for you, but that's gonna take a little bit of time. So I already have an application that is here in my IDE, and it's gonna implement this super small architecture as I mentioned. And the way we start, as previously discussed, is we declare an application, a CDK app. We define our main method, of course, and we instantiate this app. This app is a CDK app, so we have imported that statement. And that app, as I mentioned, is going to serve as the scope for our stack. We can have one or more stacks here. I'm only instantiating one, and I'm passing the application that I just declared as the scope. The first argument, as you can see, is always going to be the scope, and then for our stack, and then I need to provide an ID for the stack. And then I need to synthesize the application, because that's the way that infrastructure gets generated when we synthesize this. If we look at the tiny stack that I've developed here, we can see that I have two constructors, one with a null property and one with some actual properties that I can pass in. And basically what I'm doing here is declaring my Lambda function. So I'm using the construct that comes as part of the CDK library. I've imported that here. And I'm using the builder object that comes as part of every construct in the AWS CDK dependency. So of course you can use the constructor as well, but since we're passing in this case some properties to the function construct, then it's cleaner to use the builder method. And I pass the this keyword because the scope in which this function construct lives is actually this stack class. The stack serves as the scope for this function, which is also a construct. I'm specifying the runtime, which is for the Lambda function, which is going to be Node.js 14. You can use a more up-to-date one if you like. And I'm going to also specify where the code for that Lambda function is going to be. I'm going to tell it you have to load this from an asset, which is going to be in this directory. And there you have to look for the hello handler method. That's going to be the handler for the function. And if I go to that directory, which is called Lambda that I have here, then I have a hello file that exports a handler, and that does nothing else. I'm using Node.js, so this is written in JavaScript or Node.js, and I'm simply printing the event that came in as a parameter of the Lambda function, and I'm returning a hello world. So I'm specifying the body of the response, and I'm just saying, hey, hello JCON 2022, and this is basically what I'm doing here. After that, I'm building the via the builder object, and I have a Lambda function. After that, I wanted to define a REST API to front that Lambda function, and there is a specific construct for that in the AWS CDK library. It's a REST API that is especially for fronting Lambda function. I instantiate it as well via the builder object, and all I'm doing is again passing the scope and ID and providing the handler function. So I'm specifying this is the Lambda function, which is the one that I've declared as here, that you need to front. After building, what we can do is, build with MVN and whatnot, which is typically what we do with our Java code. But we can also synthesize this. And if I do that, sorry, it's CDK, of course, it's the CLI that we're using. If I try to do this, this takes a small while. And in the interest of time, I've already printed out the generated CloudFormation template that gets generated when I synthesize. And it's, of course, quite some lines of code. Is doing things that we didn't have to do, like creating the respective IAM roles. We didn't have to specify that. In behind the scenes, CDK wired that up for us. We only declare the Lambda function and API and the API gateway for it. So that's making things easier for us. There's a lot of metadata that is specific to CDK that you'll see that as well. But we also didn't have to declare the API gateway account, the deployment, the stage. All those things are part of specifying an API gateway. We didn't really have to do that. We just reuse that construct that comes with CDK, and that's what all we had to do, one line of code. So there you can see that it got generated also here, and that took a little while, but in the cloud, the moment we do the CDK, we can do CDK diff to take a look at the differences between what's available in my AWS account in that environment and in that account and region that I already have in my at the moment I don't have an account. I would need to authenticate, but it's always looking for that account, and it's always looking for a region that is set up as part of the AWS environment. You can use them as environment variables, as you already know. And that was it. That's all you need to do to have a first application on CDK. And now I'm going to return to the presentation and share again my previous screen. to continue with this. So my screen should be visible now in presentation mode, I hope. So let me just redo that again. And yeah. So I just want to show you quickly, before we finish, some cool things that you can do with one line of code in CDK. The one I like the most is how to grant permissions to AWS resources. This works via one line of code, via the grant methods that are available as part of CDK. If I want to grant Lambda functions permissions to access an S3 bucket, then I say bucket.grantRead. I use the grant method, and I pass the Lambda function as a parameter. And I can do the same with a DynamoDB table. If the Lambda function should be able to read and write, then I use the grant method for that, and that's all achievable with one line of code. So I didn't have to declare IAM policies and IAM rules to be passed, or all these things that we needed to declare manually previously with CloudFormation or Terraform. And that applies to all cloud resources, that AWS resources that we're able to provide access or permissions to. One very nice thing about CDK is that it tries to unify. It has a philosophy of trying to unify application source code, application configuration, and also infrastructure as code under the same roof, under the same code base, but also the pipeline for deploying not just our application code, but also for automating the rollout of our infrastructure. So this is what we do when we say that we implement GitOps with AWS CDK. You saw in the code demo that I had the code for the Lambda function in the same code base as the declaration of the Lambda function as a piece of infrastructure. So we already have these two there. But if we wanted to roll out both of them, the application code and the infrastructure and update the infrastructure with a single pipeline, we can do that with CDK. And we will again start with our CDK application. But instead of declaring a stack directly as the top level object inside our application, what we're going to do is declare a pipeline that's also a construct. When within that pipeline, we can implement other constructs, which are going to be stages within that pipeline. And within those stages, we can declare our infrastructure stack. This is where we're going to include. So it's going to be lower down in the tree of constructs that we built. And we can have stages for different environments and different stages of our life cycle of our application, one for pre-prod, one for prod. And also the interesting thing is that we can run the CDK pipeline in one account. It's going to be our CI/CD account, for example. And each of the stages can also deploy to a different AWS account. We can separate our pre-production environment in one AWS account from our production account from production environment living in a different one. And of course, the account that runs the pipeline is to have cross-account permissions to do that. We now have a single library to include that in your projects. You don't need to declare anything else with version 1. That was the case. And since I'm close to running out of time, I will only mention very briefly two other projects, which are CDK for Terraform, which is basically providing you the same. You can write via application code your infrastructure as code, and then synthesize it to Terraform templates. There is also CDK for Kubernetes that you can use to generate Kubernetes manifests. In that you develop code with programming languages that you can synthesize to those. And before I go, I want to leave you with some resources. The one place to get started if you're new to CDK is by going to the CDK workshop website. And we have many other resources and patterns that can be used for your application. And just to close off, I would like to, of course, thank you, but also to please kindly ask you to provide feedback via a 1-minute survey. I'll paste this link in a minute in the chat, or you can scan the QR code here. It's quite valuable for me to improve, and to AWS to improve our content, improve our presentations, and bring you more valuable content. So with that, I think we have only 2 minutes for Q&A, but I will go to the chat window and try to see if I can see some of the questions.
There is only one question, if I see correctly, and the latest one.
Yeah, how can we parameterize to our deployment for our infrastructure, CI/CD environment variables? You can also use them. So CDK will also look for environment variables. You can declare this also in your CDK pipeline via code, or you can load this from an external service where you have your application configuration, such as, for example, application. So parameter stored, for example, on AWS, that's where you can take your parameters. You can do this via code, or it can be environment variables also that are running in the environment where you run this. And of course, you will get the slides. I will make them available to the conference organizers and via the website platform. Yeah.